to 6.3, which is conditional probability. This is only for the period 7 class, and it should be Friday. So what you guys should have in front of you, the sub should have given you a classwork which goes along with the video. So as you go through this video, just kind of fill out the classwork, and then that'll more or less be it. But I kind of wanted to start with this warm-up. So I, read the 3 questions and then pause the video and then see if you can answer them. You can just do that independently and look around and see who's in the class. All right, so if you have done that already, find the probability that I choose someone whose name begins with a vowel to answer this question. Well, I'm not here, so it's 0, but whatever. But if you think about the people whose name begins with a vowel, just assume everybody's in the class, even if they're not, if they're absent. But you have, I think, just Emma and Angela will be the only 2 kids in the class. Forgive me if I'm wrong, whose names begin with a vowel. So the probability that I choose one of the 2, so there's 2 favorable outcomes, and in your class there's only 11 possible outcomes. So answering the first question, pick on somebody whose name begins with a vowel. So then another person whose name also begins with a vowel, there's only be 1 left. So assuming that I chose someone whose name begins with a vowel, Emma or Angela, there'll only be 1 left out of the 10 people, right? And that would kind of give you your probability. So the probability is just going to be 2 over 110, or 1 out of 55, which you can convert it to a decimal and just say, okay, 1 out of 55, it's going to be, well, and you can always multiply it by 100, but it's going to just be 1.8, oops, 1.8%, and then you'd be done. So it's not good odds. Right, now if we look at the second one, find the probability that I call on someone whose name begins with a vowel to answer the second question, given that I called on a student with the vowel the first time. So it's really only looking at this probability. So it's not really taking the probability of both. It's not the probability of event A and event B. It's just the probability of event B given A has already happened. So if I called on somebody first whose name did begin with a vowel, that would only leave Emma or Angela left. So it would only be a 1 out of, and the sample space would be down to 10 because I couldn't call on that person again. So it would just be a 1 out of 10 chance, or a 10% chance, right? Which would be much better odds than if you looked at both of them. But it's because the criteria or the condition was given that I already called on somebody whose name begins with a vowel. Right, and that's kind of what the difference is one is the probability of 2 events happening, and you multiply them. They're not independent. One is that, like, the probability has changed, but you still do multiply. The second thing is that given a certain criteria has already happened, what is the probability now of the second event? So it's really only the probability of B, but it's given that A has happened, and that's kind of what this lesson is about. So this is the example we're going to look at mostly today. So event A is you fail the math test on statistics. Event B is you hit my trash can, right? They could be independent events. They may not be. You can't really tell from that prompt. And we've talked about some of the ones in class too. You don't really know. So we can test to figure out if something is independent or if it's actually dependent, which we just call conditional probability. So you kind of look at the probability of A is kind of seen as blue one. The probability of B is seen as blue one. The probability of A and B is kind of like the intersection of both of those things. So they're both going to happen, right? It's really the same thing as we've done before. It's the probability of, it's the number of favorable outcomes, so they both happen, out of the entire sample space, which would just be the probability. So what this is looking at is the probability of B given A. That line that you kind of see, kind of read it as given, right? So the probability of B given that A has already happened, right? Given that we already called on Emma to answer the first question, what's the probability I call on Angela, or vice versa? And that's what we're really going to look at. So there's a mathematical formula to it, but it's really, I kind of want you to understand why it works. It's the probability that they both happened, and then you divide it by the probability of A, which would be the entire sample space. That's the same thing as the number of favorable over the entire sample space, right? That would give you the probability of B given that A has already happened. We'll make more sense of this in a minute. But like event A, you failed the math test. Event B, you hit my trash can, right? The probability that you hit my trash can, given that you've already failed the math test, right? You would look at the probability of B and A together, you failing and hitting my trash can, divided by just the probability of A, just you failing, right? And that's kind of what we'll be doing as we go through these slides. So I'll have to give you some of these numbers before you can really figure anything out. But let's say that you were told the probability of A, which is failing a math test, is 0.20, right? 20%. The probability of B, just any old day, the probability that you hit my trash can is just 5%. Maybe you kick it over, maybe you just nudge it, I don't know. And I'm also going to tell you that the probability that they both happen is 0.03, right? This is before A or B has occurred. So this is just kind of like the numbers of each thing possibly happening, right? We somehow had that data, right? Now we are told that event A has occurred. It's already happened, right? You've already failed the test. What is the probability that B will occur now? Probability of B given A, right? And this kind of just explains the same thing. So 20% chance that you fail the test and a 5% chance you hit the trash can, right? And then a 3% chance that they both just happen on their own. So what we want to look at, we kind of already moved this, but it's supposed to be like this. What is the probability of B given A? It's not 5%. Even though 5% was the probability you hit the trash can, that was not necessarily, that was just happening on its own, not after the test. Maybe the test has influenced your likelihood of hitting my trash can, right? It's also not 3%. 3% is the probability of A and B, not B given A. So what you want to do is use that formula I gave you in the last slide. You get the probability of B given A is the probability that they both happen on their own, which is 0.03 or 3%, and divide it by the probability of A happening, which would just be you failing the test, right? That's the same thing as the number of favorable outcomes. They're both happening, divide the sample space, you failing the test, right? So in this case, it's 0.03, which is the probability that they both happen, 20% or 0.2 the probability that you fail the test, and you get 0.15, which is 15%. So notice how that's a new number, but that's the probability of B happening. That's the probability that you will hit my trash can, given that you failed the test already, right? And that's 15%. So what I really want to look at now is the probability, the difference between the both of them happening and then one given the other. And you might already have an understanding of it. But B and A could be independent and not conditional probability, meaning that they are dependent events, but you may not know, right? So you kind of need to use this to figure out if they are, right? So 20% chance you fail, 5% chance you hit the trash can, 3% chance that they both happen. Either order, but the probability of B given A, which we just figured out, is 15%. And you might already have an idea of what that number kind of signifies. So this is just the same prompt. I didn't need to rewrite it, but that's okay. The probability of B occurring on its own, which is just the probability of B, which in this case was 0.05, so 5%. Now, after event A has occurred, what is now the probability of B, which is probability of B given A? Which from the 2 slides ago, we figured that that was 15%, right? So after A has occurred, the probability of B happening is now up to 15%, right? Does that make sense? Well, we could probably make sense of it. You could think of a scenario why you failing a test would actually influence you hitting a trash can, right? You may be completely overwhelmed and you know that you failed the test right away and you're just not paying attention and you trip over it. You may be pissed that I put certain questions on the test, so you just decide to kick it over because you're angry. But for whatever reason, the probability or the fact that you have now failed the test will increase your odds. It'll make you 3 times more likely. You're still not likely, but you're 3 times more likely to hit my trash can after you failed the test. So that means that they are not independent, right? They are related. It's conditional probability. Another way of saying that, they are dependent events. The probability of B happening depends on whether or not A has happened, right? Because on its own, it's only 5%, but if A happens, it's up to 15%. So when are events independent? Well, basically, if the probability of A given B, I kind of switched them around, but it's the same thing. If the probability of A given B equals the probability of A, and then vice versa, then that would have to mean that they're independent, right? If the probability of one event happening, given another event is happening, is the exact same thing as the event happening on its own, what does that really mean? Well, it just means that whatever B was, it had absolutely no effect on the probability of A, right? If A given B is the same thing as the probability of A, then B doesn't really matter, right? Which means it does not have an effect on the probability of A, which means that's your definition of independence. So, typical example, right? You have the Celtics win. Let's say there's a 70% chance that that happens. We'll call that event A. The Red Sox win. That's event B. It has a 25% chance of happening. And I also somehow figured out that the probability that they both win is 17.5%. Right? Are these independent or are they dependent? We may not know yet. But if you run the test, if you do the probability of B given A, probability that the Red Sox win given that the Celtics win, and use your formula, right? It's the probability of both divided by the probability of A, it's the last one. You'll get 0.175 over 0.7, which is 0.25. 0.25 happens to be the probability already that the Red Sox were going to win anyways. So the probability of B given A is equal to the probability of B, which just means event A, the Celtics winning, had no effect on whether or not the Red Sox were going to win, right? And you do want to show the test both ways, although it's basically very simple algebra. It's like it's 6 divided by 2 is equal to 3, and the next one's going to be 6 divided by 3 equals 2, right? It's going to work both ways, but still show it because that's how you prove basically if something's independent. So definitely want to show both ways on any assessment. But so again, just the probability of A given B, right? The probability that the Celtics win given that the Red Sox win, right? It should be the exact same thing. A different number, but it should match the opposite probability. So you take the probability of both, divided by the probability of B, you get 0.7. Well, 0.7 was the exact same percentage or probability that the Celtics would win anyways. So the probability of A given B is the same thing as the probability of A on its own, which just means B has no influence, which means the two events are definitely independent. Right? And that's how you prove independence. So, just about the last example I think I have for you. Yeah. So let's say you hear a Metallica. Let's say you've heard a Metallica song on the way to school. Maybe you listen to that station and you have a 15% chance of that happening on its own, any random day. Now you have only a 1.33% chance that you're going to break your laptop on any given day, right? So, and then we also have data that shows the percent that you break your laptop and you hear a Metallica song on the way to school is 0.2%, so not very likely at all. But are those events independent, right? And we can kind of do this. So you'd have to take the probability of one given the other. So we'll say probability of Metallica song given your laptop breaks. Although you can do it in either order. We'll do it the opposite way. Might make more sense, but you do need to prove it both ways. So the probability that your laptop breaks given you hear a Metallica song, right? That should equal the probability of both, which in this case is 0.2%, over the probability of just hearing the Metallica song, which is 0.15 or 15%. And this should be 0.02, I just realized. 0.002. If it's 0.2%, that means we have to move it 2 more, so 0.002. And that will give us 1.333333%, right? So 1.33%, right? Which, if you notice, that is equal to the probability of you breaking your laptop on its own. So what does that mean? The probability that you break your laptop, given you heard a Metallica song, is the exact same thing as the probability you would break your laptop in the first place. So the Metallica song had no effect on whether or not you broke your laptop, right? So these would be independent events. Now again, I'm not going to show it, but you still do have to do this the other way to show that it's actually independent. So you'd have to do 0.002 over 0.0133, and that would give you the 15%, which would equal the probability of just hearing a Metallica song. So the answer is yes, they are independent. Or you could say they are not dependent, or it's not conditional probability, same thing. And if you're thinking, well, this is 1.333333%, this is only 1.33. If you're within 1%, we're going to say that they are still independent, right? So sometimes with smaller sample spaces or different things, it could be off by a little bit. But if you're within 1%, then we're just going to go ahead and say it's independent. So, even if this was 1.6%, I'd still say that they're probably independent. But that's kind of just a rule of thumb we'll use for this class. Right? Now, if we change the chance that you're breaking your laptop to 3%, well, then all of a sudden we would do the same problem. We would do the same problem, the probability of L given M, probability you break your laptop given you hear a Metallica song, and we would still have the 0.002, which is probability of both, divided by the probability of a Metallica song, which is still 0.15, and on the calculator we would still get 1.33, but that is not equal to 3%, which is the probability that you would break your laptop, which just means the probability that you break your laptop given you heard a Metallica song is not the same thing of you breaking your laptop on its own. It actually went down, which might be contrary to what you might think, but it's either way, it's not the same. So for whatever reason, you hearing a Metallica song lowers the chance that you actually break your laptop. Right? We might want to change this to 1.5% or 0.5% or something. But either way, it's changed, so you can kind of see that the probability or the fact that one event has happened is now affecting the other one. So that would happen if we changed it. Obviously, because it was 1.33% in the original, right there, and that was the exact same thing as 0.002 divided by 0.15, then the two things are independent, right? But you could see how if we change one number, obviously that would affect the answer. And that's pretty much it. So what you guys can basically do now is just start the homework, and I think that's probably all we need to do. There is a 6.3 activity. Yeah, actually don't start the homework, I'm sorry. Do the activity first, which is something that looks like this. It's 10 questions, it's on Schoology, and then from there, your homework is just some book work. It's actually not many questions. I think it's only 5 questions, but that's also posted on Schoology. All right, so good luck.